I've had lots of times when I know the GPIO is connected correctly and my program is correct, but nothing is happening. The program isn't reading a push button, or an LED isn't lighting up, or it would be really handy to be able to watch the GPIO status in real time so I can detect when buttons are being pushed. Well, Piscope to the rescue. This software utility is easy to install and indicates the status of the GPIO pins. Here you can see what happens when I push our button, and I can tell that it's connected to GPIO 21. Let's take a look at how to use it.
Hi, I'm Mark Neiman Ross, and welcome to this week's edition of Raspberry Pi Weekly. Every week, we explore the Raspberry Pi and share useful tips.
Piscope is easy to install. On your Raspberry Pi, open up a terminal window. Type in wget.mei.uk/rpi/piscope.tar. And this will download the Piscope tar archive. Now you can unpack the file you've just downloaded with tar xvf piscope.tar. Now we'll cd to a new directory. We need to make the HF version. Make HF, and then make install. That's all there is to it. Now we'll start up a daemon. It's called pigpiod, and to do that, I type in sudo pigpiod, and now I'm ready to start Piscope. So I type in sudo piscope, Piscope, with an ampersand after that, and that means that it'll run in the background. In a second, it opens up Piscope for us, which we can bring up to screen here. And I'll make that a little bit bigger so we can take a look at it. Now, initially it turns black, but as soon as you do a signal or something to the GPIO, you'll see that all sorts of lines appear. These green lines indicate the status of each of the GPIO pins. So, for example, if I push our button previously, you'll see that one of the lines change. Right in the center, you can see how the line goes up. This is indicating that GPIO pin 21 is active, and that's where my button is attached. Now I still have my telephone connected from the previous Raspberry Pi Weekly series, which is really interesting because I can watch how the phone affects the GPIO. In this case, I'm going to dial 1. And you can see two things happening. First of all, GPIO 14 has triggered, and GPIO 15 indicates that there is one pulse that was sent down the line. If I dial 4, you'll see that, again, line 14 is triggered. Line 15 indicates 4 pulses that have come down the line. I can see not only what is being triggered, but also when it's triggered. So Piscope has a couple of tricks. Under the miscellaneous menu, you'll find GPIO and triggers. Let's look at GPIO. This allows you to select which GPIO lines you want to watch. So I don't need to watch 2, 3, 5. Let's just watch lines 14, 15, and 16. Now when I dial, I have a real clear indication of which lines are active. The second miscellaneous item is triggers. This is what will turn on a recording of the signal paths. I'm going to turn on a falling signal for pin 14. The samples indicates how long the recording is. Now when I dial 5, it will take 100 samples and then I can press play to play back the capture. There are lots of ways to debug the GPIO interaction. Piscope is a handy tool for checking the entire spread of GPIO pins and to examine if timing is important.
Thanks for joining me for this episode of Raspberry Pi Weekly. Be sure to join the LinkedIn group and check out previous episodes on LinkedIn Learning. I'll see you next week with more Raspberry Pi adventures.